Hello everyone. This video explains how to write domain and range in various ways, including interval notation and set notation. Domain is all the x values that are possible in a relation, whereas the range is all the possible y values in a relation. In a function, we can see the ordered pair of x and y, just like x comma y, in a coordinate form. We'll see three ways of writing the domain and range. First, we can write all the domain and range values explicitly, and there are two short forms of writing the domain and range, which are interval notation and set notation. Say we have a relation given in a table that has x values of 2, 3, 4, and 5, and y values are -3, -2, -1, and 0. In this case, we can write down the domain and range explicitly in a list form inside the curly parentheses. So the domain is 2, 3, 4, and 5, and the range is -3, -2, -1, and 0. When we write those domain and range explicitly, then we need to use the curly parentheses. The relation that we have in a table to a graph, and those points have a discrete relationship as those dots cannot be connected. So we cannot really use the interval notations to describe those domain and range. However, we can use the set notation to describe the domain and range here. Set notation has a general form. For the domain, they have a general form of x bar condition 1, comma, condition 2, comma, and if you have more condition, you can add on. For the range, we can say y bar condition 1 and condition 2. Again, you can add as many conditions as you needed. So to describe the domain in a set notation, we can say that the domain for this relation is curly parenthesis x bar condition 1. So the x value is bigger or equals to 2. So we can say x is bigger or equals to 2. However, it is smaller or equals to 5. And the next condition that we will write is about those numbers. We don't really include all the real numbers for those domain, as it doesn't really include 2.1, 2.2, those decimals here. And 2, 3, 4, and 5, those are the natural number. So we use that the x includes all the natural number, which we'll write it as a n that represent the natural number. And for the range, we can again write it in a set notation using the curly parentheses. Y bar, y this time is bigger or equals to -3 and smaller and equals to 0. Those -3, -2, -1, and also 0, they are integers, and we can say that the y value includes all the integer, which we write it as a c. So how can we write those interval notation? We can use the regular parenthesis and the square parenthesis. When we use the regular parenthesis, the number is not included. And when we use the square parenthesis, the number is included. For the first line graph, those dots represent x values. So we can write about the domain of this line graph. And those dots are discrete as they are not continuous, and those dots are not connected together. In this case, we have no choice but to write all the domains explicitly. So the domain for the first line graph is 0, 1, and 5. For the second line graph, we're also talking about the x, so we can write about the domain of this line graph. And this is a continuous graph, so there are two ways of writing the domain. As it includes all the real number, we cannot write every single values of this continuous line. Therefore, we can represent this domain using either the interval notation or set notation. The number starts from -3 and it ends at 5. However, the value does not include the -3, so we can use the regular parenthesis here and write which number that it starts, comma, and we can write where it ends, which is 5. And as it includes the 5, we can use the square parenthesis. Also, we can write domain in set notation using the curly parenthesis, x bar condition 1, that x is bigger than -3, but is smaller or equals to 5. And the second condition is those numbers includes all the real numbers between those two values. So we can say x includes all the real number. Graph number 3 also represent all the x values. So we can write about the domain again. However, just like the second line graph, we cannot really write all the domains explicitly because it is literally impossible to write on this line. Therefore, we'll use, again, the interval notation and set notation. The smallest value of this line is 1, and it includes the value of the 1, so we'll use the square parenthesis, and it starts at 1, and it includes all the values that is bigger than the 1, so the domain is from 1 all the way to infinity. And when we use the infinity sign, we do not include the infinity number. So we use regular parentheses. This is same for the negative infinity sign, which we'll see in a graph 5. And again, we can write this in a set notation that using the curly parentheses, x bar condition 1, that x value is bigger or equals to 1, but is smaller than the infinity. But this is awkward to write, so we can just write it as x bar x, that is, x value is bigger or equals to 1. Again, this is the continuous graph, which includes all the real number, so we write down the second condition as x includes all the real number. Graph number 4 has the discrete relation, and it represents all the y value. So now we can write about the range. There are two ways to write the range of the line graph. First, we can write all the values explicitly using the curly parentheses, -4, -3, -2, -1, 0, 1, and 2. Also, we can write the range in set notation using the curly parentheses, y bar, y is bigger or equals to -4, but smaller or equals to 2. However, unlike those line graph number 2 and 3, we don't include all the real number in this case, as they are not continuous graph, so we can write the second condition as y includes all the integer, which we write as a c. You cannot really use the natural number to describe this range because natural number only includes those positive integers. Graph number 5. describes the y value, so we can write about the range. We can write this in two different ways, again, using those short form, as we cannot write those values explicitly. We can use interval notation and set notation. The biggest number of this range is 2, includes all the number that is smaller than 2. So we can say the value starts from the negative infinity all the way to 2, but it does not include the 2, so we can use the regular parenthesis. And to write this in a set notation, we can write the curly parenthesis y bar. The first condition again is y value that is smaller than 2, and we can describe those numbers on the line that this is the continuous line, so we can say that the y includes all the real number. Lastly, line number 6. Again, it describes the y value, so this is the range, and as this is a continuous relation, we cannot write every single values, which includes all the decimals here, so we can write it in a interval notation. The smallest y value that we have is -5, and it includes the -5, so we use the square parenthesis. So -5 to 0, and we include the 0. And the next line starts from 4 here, and it does not include the 4. So we use the regular parenthesis, and it starts from 4 all the way to the positive infinity. And again, when we use the infinity or negative infinity, we do not include the infinity as a number, the regular parenthesis. Again, we can use the set notation using the curly parenthesis. Y bar, the first condition is the y values that is bigger or equals to -5 and smaller or equals to 0. So y is bigger or equals to -5 and smaller or equals to 0. And the second condition is the y value that is bigger than 4, but does not include the value of 4. Lastly, we can describe those y values. Since this includes all the real number, as this is a continuous line, so we can say that the y value includes all the real number here. Thank you very much for watching the video, and good luck on studying.